In this video, we're going to start with chapter 2, so which is the topic of functions. We're going to discuss two subtopics, 2.1 functions, for which we're going to discuss basic concept and also domain and range. And then for 2.2, we're going to discuss the graph of a function. Okay, so basically what is a function? So function is, the rule of a function is that when you give an output, it produces a single, when you give an input, so it produces a single output. So this is going to be the condition. So output can be one, so it could be many, but it has to produce a single output. It can only produce one thing. It cannot produce more than one. For example, so if I were to give you a simple analogy, so I have a machine. Okay, so this machine right here, so I'm going to give the machine flour, I'm going to give it yeast, I'm going to give it sugar. Okay, so this is going to this is my machine, and what happened is that, so then put over here machine, so it's going to produce one single thing, which is going to be bread. So yes, this is going to be a function, because no matter how many input I give, it's still going to give only one output. The product only one, so which is going to be bread. It can only produce one thing. Okay, example number 2. So I have another machine, so this is going to be my machine number 2. Okay, machine number 2, machine number 1. So I give it pretty much the same thing. I give it flour, I give it sugar, I give it yeast and other ingredients. So what happened is that this machine, instead of can only producing one thing, bread, it can produce bread. It can also produce cake. It can also produce pastries. Okay, so what happened is that instead of like producing only one thing, one answer, so it can produce more than one output. Let me put over here, more than one output. So for this case, what happened is that this machine is not a function. So remember, the key point is that like your function, it's going to be called as being a function if it can only produce one output. Okay, that is the condition of being a function. So functions, there are two types of functions. So function could be one-to-one, and it could also be one-to-many. So what is the difference between one-to-one and one-to-many? So one-to-one means, so when I give one value, okay, it's only going to produce also one value. Okay, that is going to be one-to-one. So this value, so it's going to give another value. For example, so if I have f of x equal 3x, so if I have x value equal 1, what happens is that I'm going to substitute here equal 1. This is going to equal 1 as well. I will get f1 is going to equal 3 multiplied by 1, so it's going to be 3. So if I have x equal 2, I'm going to have f of 2. This is going to be 3 multiplied by 2. That is going to equal 6. So what happened is that, so one value that I give can only be mapped to one value. 3 can only come out from 1. 6 can only come out from 2, and so on. Okay, so there could be no value such that when I substitute f a equals c, so when I substitute fb is going to equal c as well. So there is no such value for the case of one-to-one. Okay, so on the case of many-to-one, so it's going to be the opposite. So many-to-one, so that's a super hideous handwriting. Let me write that better for you. For the case of many-to-one, so it means that two values, the output could share, so two different values could share the same output. For example, I have two values. This is going to be the value. So the same input, so I'm going to have the same output. So the different two inputs can share the same value of output. So the easiest example is going to be for function f of x equal x squared. So what happened is that if I have x equal 1, so I will get f1 equal 1 square, and that is going to equal 1. But if I have x equal negative of 1, so I will get f of negative 1 is going to equal negative 1 square, and it's still going to equal 1. Okay, so what happened here is that even though this is a different value, 1 and negative 1, so the output comes out as being the same value, which is going to be 1. So this is going to be the case of many-to-one. So many input values can give you the same output value, but one-to-one, no. Like one value, one output, and so on. Okay, so that is the difference between many to one and one to one. Okay, but remember I told you, like a function cannot produce more than one output. What happened for this case here is that, so for example, if I have a f of x, so let me put a different pen for this. So if I have f of x is equal plus minus square root of 4, so I will have plus minus of 2. So it could be 2 value. So it could be 2 and it could also be negative of 2. So that is why for this case, remember you cannot have more than 2 output. So therefore it is not a function. Okay, so when you give one value, it should only be, so this is f of 4. So when I substitute over here equal 4, become f of 4, it's going to be plus minus square root of 4. So when I give one value, one input value, what happens is that I come out with 2. No, so that is not a function. Okay, so output should only be 1. So these are going to be the basic concept of functions. Again, I'm pretty sure you have seen this before, so this is just going to be review for you. So I have a function f of x, which is equal 3x squared plus 1. So for a, what I'm going to do is I'm going to find f of 2. So the concept is going to be very simple. If here I'm using x, so the variable with the variable supposed to substitute is going to be right here, and treat it as you have a bracket around the 2. So when I have f of 2, so now all the x, so let me put a remark over here. Okay, substitute all x to 2. So what happens is that I'm going to end up with f of 2. Okay, so where's the x position here? X, and this is going to be x. So wherever I have x, now it is going to be replaced by 2. And this is going to be 3 multiplied by 2 squared plus 1. So which is going to be 4 multiplied by 3. That's a 12 plus 1. That is going to be a 13. So whenever that is x, I'm going to substitute that by 2. So that will be the idea. So when you change the input, whatever that goes in the bracket, the independent variable, so the right hand side is going to change as well. Okay, so now I'm going to have a look at b. So b is going to be pretty much the same idea. So f of x is equal 3x squared plus 1. So the only thing that happened now is that I have f of x plus h. So every single time you come across x in your function, so you are going to change that to x plus h, and the same go for this one as well. So it's going to be 3, just copy it down. So now I come across x is going to be x plus h squared, and then plus 1. And then you're going to simplify this. When I expand, I will get x squared plus 2xh plus h squared plus 1. So it looks like there's actually nothing I can simplify right there, because everything is now in terms of constant. So you can simply leave it like this, or if you can expand as well and leave it like this. But in order to minimize the mistake, if you cannot simplify it, simply leave it as being the top. Okay, so I'm just going to leave it until here. That would be better. It avoid mistakes. Okay, next, C. So what's my question for C? For C, I have f of 4 alpha plus 2. So it's still going to be the same idea. So whenever I come across x, so now it's going to be changed to 4 alpha plus 2. So therefore my function is going to be 3. So now it's going to be 4 alpha plus 2 squared plus 1. So I can actually simplify, because this is going to be constant. So I have to expand, and this is going to be 3. So I'm going to have 4 squared, which is going to be 16 alpha squared plus 2 multiplied by 2 multiplied by this. So 4 multiplied by 4, that is 16. And I'm going to have 16 of alpha plus 2 squared, which is going to be a 4 and plus 1. So now let's simplify this. I'm going to end up with 16 multiplied by 3. So that will be a 48 of alpha squared. Again, 16 multiplied by alpha. So that is going to be 48 of alpha plus, so this 2 is going to be 12 plus 1. That is going to be a 13. So that is going to be the outcome. So let me check if this is right. I think so. 14 for 16. 2 multiplied by 2, that's a 4. Divided by 4, 16. Yep, that is correct. And 16 multiplied by 3, that will be a 48. That will be the outcome. So the idea is that do not get intimidated. So no matter what variable we use, it's still going to be the same idea. It doesn't matter if you're using x or using constant x plus h or 4 alpha plus 2. So the concept is that whenever you change the variable, so the right hand side is going to change as well. So simply replace the right hand side of the equation where it is the same as the variable. So if here is x, so replace the x. If you have a, replace the a, and so on the right hand side. So this will be exercise for you to try. And next we are going to have a look at domain and range.